Okay. You're 25, so that's we're 25, so that saves you from getting the quiz right now, because the earlier section they have less than 25, so they have to take the quiz at the beginning. So we're going to continue with the last equilibria, and this has something to do with solubility equilibria. So there's such a thing as what we call solubility rules that qualitatively describes the solubility of a given compound based on the ions that they have. So you can have a solubility rule statement like all nitrates are soluble, all acetates are soluble, all group 1A metal ions are soluble. Or for instance, if you have silver chloride, all chlorides are soluble except, or we could say it's not only chloride, all chlorides, bromides, and iodides are soluble except silver, mercury, and lead. So you answer the question, is it soluble, as yes or no, if you have a solubility rule. But if you're going to look at silver chloride, it is soluble, but not like what we call the NaCl. When we say it is soluble, the amount that it dissolves is, we could say, in milligrams level per liter compared to the grams per liters of the other chloride. So if you have this so-called sparingly soluble or insolubility rules, insoluble substances, what you have there is a system at equilibrium where small amount, let's say of silver chloride, dissociates to give you silver ion and chloride ion. Okay? And if we're talking about solubility, we can write the K expression of this as this. But what's the problem with this AgCl? This is what? A constant. So you can incorporate that, giving you the new K, KSP, that is the solubility product constant. And this is what we call the KSP expression. Okay, now if you have a KSP expression like magnesium fluoride with this one, so this is how the expression looks like. So what you can say, it follows the law of mass action principle. The one that you learn in KC, the one that you learn in KA and KP. If it's like this, it will be like this one. And if it's like this, it will be like this one. Okay? So KSP is just, we could say, a way to tell us the solubility of a given substance. And if you're going to look at this, these are the KSP values of some slightly soluble ionic compound. Now, what information it can convey? Can we use it to compare one another? The answer is yes and no. Yes, if they have the same type of compound. No, if they don't have the same type. So for instance, you can compare silver bromide, silver chloride, and silver iodide. Why? Because all of them has a positive one and a negative one ions that form. So by just looking at the KSP value, you can determine which is soluble and which is insoluble. Okay, so usually the KSP value would tell us the higher the KSP, the more soluble it is. For the lower the KSP, the more insoluble it is. So I can ask you the question, which is the most soluble between the three? And which is the most insoluble? Anyone? Sige nga. Doon sa tatlong naka-check. So silver chloride is the most soluble because that has the highest KSP value. Now, what is the most insoluble? Okay, it is the silver iodide because it's 10 to the 7 negative 17 compared to the bromide that is 10 to the negative 13. Now, how are we going to compare the solubility of these two? Which is more soluble? Maybe not bromide, but this one. Silver chloride versus carbonate. So if we follow the KSP, silver chloride is the carbonate. Is soluble compared to the carbonate, but as you can see, they are not of the same type. Okay? One has a positive 1, negative 1 ion, while the other one has a positive 1 and a negative 2 ion. So how are we going to solve that? We will solve that later and answer the question, which is the more soluble between the two? Okay? Usually, the way that we solve it to determine which is more soluble is we determine the molar solubility. Okay? So molar solubility, this is the number of moles of solute dissolved in 1 liter of saturated solution. Now, compared to the solubility, this is the number of grams of solute dissolved in 1 liter of a saturated solution. Now, there are two types of calculation here. One, when we're given the solubility of compound, and we are asked to determine the KSP. That's the first thing that they did. How do you think they were able to get the KSP table? So they look at the solubility of each compound. They determine the molar solubility of it, and then determine the concentration. Now, once you know the KSP, you can also know the solubility or molar solubility. What can you say between the two of them? They're just the reverse. This one is here, this one is here, this one is here, and this one is here. So that's what we're going to solve today. And I want you to look at the link that you have in the what we call module. So I want you to look and watch the videos that you have here. Okay, you need to do that because I have we could say feeling that the third exam will be calculated laden questions. Okay. So let's try work on some example. So let's say what's the solubility of silver chloride, and then later on we're going to compare the silver carbonate. So we'll have an idea which is more soluble. So the way that we're going to do it, silver chloride, solid, silver ion, chloride, both aqueous. So you follow the ice table as we have before. You don't include this because this is a constant, so you just follow here. So this is a plus S, so instead of X, we use S for solubility. So at equilibrium, this is what we have. So KSP equals to silver ion times chloride ion. So 1.6 times 10 to the negative 10 equals to S times S. So S is just equals to what? The solubility of the square root of 1.6 times 10 to the negative 10. What is that equal to? Anyone? So 1.3 times 10 to the negative 5. Are we done? Are we done? Are we done, class? Okay, we're not, because this is what? Molar. So 1.3 times 10 to the negative 5 moles per liter. So we're asked for grams per liter. So what do? We multiply it with the molar. And the molar mass of this is equals to, what is that? 143.36. So that will give us what? Grams per liter. And that is equals to 1.9 times 10 to the negative 3. Now, let's compare it with a silver carbonate. So silver carbonate, what do you have here? 0, 0, plus 2s, plus s. So you have 2s, and then you have s. So if you're going to look at this, so KSP silver plus squared times CO3 2 minus. So you have here 2s squared times s. So you have 4s cubed. And the KSP that we have, so let's go to the table. Silver carbonate, 8.1 times 10 to the negative 12. So what do? We divide by 4 and cube root to get the s. And s is equals to what? (1.3 times 10 to the negative 4. Everyone get that? Now here alone, you can compare it with the value that you have there. So which is more soluble between the two in terms of molar solubility? So it is the silver chloride or the silver carbonate, which is more soluble. So alin dito mas mataas, yung 10 to the negative 4 or 10 to the negative 5? Okay. Which is more soluble? So we're comparing molar solubility. So this is 1.310 to the 4, and this is 1.310 to the negative 5. So which is more soluble? The carbonate or the chloride? Because ang dami sumagot initially na chloride. So based on this molar solubility, okay, the carbonate is more soluble. And look at the KSP, it's lower. But as I've told you, they're not the same type. Okay, and then we can multiply it with the molar mass, which is equals to what? 200 something, 275.7. So this is equals to how many grams per liter? Anyone? Point 036. So in terms of solubility, carbonate, silver carbonate is more soluble. You have 0.036 gram compared to this one, which is just 0.0019 gram. Clear? Claro? Now, to further look at the relationship between the KSP and the solubility, this is the relationship if you have different types. This is what I told you. You can only compare them if they have the same type. Like this one, SS, SS, okay, 2S and S, S and 2S, S and 3S, and then 3S and 2S. Because based on the relationship that you have there, the way that you're going to get the solubility is going to be different. So if both of them are positive one, positive, a negative one, or positive to negative two. So S is just the square root of the KSP. But if it's the different combination of type, they have their own, like this one in here. So I like you to watch the video link in module, and I will also send you the link of my short video. I have already the short video for the acids and bases and also the KSP. What I don't have is the equilibrium. Baka mauna pa yung quiz nung acids and bases, okay, and solubility kaysa doon sa KC, because I have to make some problem also on that. Wasn't able to do today because my body is really sore. Okay. I have my second booster yesterday. Yes, you can only compare them if the cation or anion are the same, but if not, you cannot do that. So when you can compare that, they have the same type of cation and anion. The higher the KSP, the more soluble they are, or the lower the KSP, the more insoluble they are. Okay. Now, another problem that you are going to deal here is predicting if there will be a precipitate if you have certain concentration of the cation or anion that makes up compound. Okay, so the way that you're going to look at this is you look at the Q value and compare it with the KSP value. So the Q value that you have here, that's just your ion product. Okay, the concentration of the cation times the concentration of the anion. But the way that you're going to do the calculation depends on the KSP expression. So if the ion product or Q value is less than KSP, you have an unsaturated solution, so there is no precipitate. If both of them are equal, you have a saturated solution and you have a system at equilibrium. But if the ion product or the Q is greater than the KSP, you have a supersaturated solution and you will form a precipitate. And I have an example here in addition to the one that is to the module. So I would suggest, if I'm not mistaken, I think the exam is in 2 weeks, right? Tama ba? I think around December 9. Okay. So we're going to have a busy weekend from this weekend to next weekend to prepare you. So for instance here, you are asked if 2 ml of 0.2 molar NaOH are added to, when added to 1 liters of 0.1 molar of calcium chloride if a precipitate would form. So the way that you're going to analyze this is you separate the ion that are making up each of them. So these are the ions that you have. And from that, you can predict which one will precipitate, or usually they will give you the KSP of the material. So what do you think is the material that will form here? So it could most likely be this and this, because all group 1A are soluble, all chlorides are soluble, except mercury, lead, and silver. So you're going to be given here the KSP of your calcium hydroxide that is equals to, you're going to look at the table. It's always like a table. 8.0 times 10 to the negative 6. So you still have to write the KSP expression, but maybe the way you're going to do it is you base it on the reaction. And the KSP expression, you're not going to write the ice table. All you need to do is write the KSP expression, calcium 2 plus times hydroxide squared. And what do? You're going to determine the concentration of this and this based on the given amount. Okay, so for the hydroxide, initially you have what? 0.20 molar of the hydroxide, 2 ml of that. You mix with 1,000 to produce 1,000 to 2 ml. And what do you get here? And then the same thing with the calcium. So you have 0.1 times 1,000 ml over 1,002 ml. So you have this one. NHL in the slot, Thompson. So what do you have? So this one will give you point. So if I'm not, this is 2, okay? Not 200. This is 2. See that? 2 ml. So it is 4.0 times 10 to the negative 4. And this one will just be around 0.1, right? So the way that you're going to do is get the ion product of that. So you have here 4.0 times 10 to the negative 4. And then this one is 0.1 squared. And what do you get? 4.0 times 10 to the negative what? Negative 6. Will this precipitate or not? There will be what? What's the relationship of Q versus KSP? So this is the KSP, this is the Q. So it is less than, so there's no precipitate. Okay. Question. So let's go on the common ion effect. So this is the third time we have the common ion effect. In chemical equilibrium, the presence of the common ion shift the equilibrium or favors the reaction to the left, okay, or the backward reaction. In acidity, the presence of a common ion decreases the dissociation. So the same thing happened here. The presence of a common ion decreases the solubility of a salt. Okay, so we can compare the value of the molar solubility of silver bromide in pure water and compare it with the one that contains a common ion, okay, silver bromide. So I can put this like this. And then the ice table that we have, nothing, and then plus S, plus S. So we have S and S. Okay, so we have the KSP equals to silver ion times bromide, producing what? The KSP value here would be equals to 7.7 times 10 to the negative 12. So you have S times S. So that means to get S, that's just the square root of 7.7 times 10 to the negative 12. And that is equals to what? Hit 2.8. Wait, negative 12 ba? Ang labo ng mata ko eh. Baka mali ako ha. Seka natin. Double, I just want to make sure. I think it's a 13. Oh, it's a 13. Sorry. My bad. So kapag 13, ano yung square root nun? This should be a 13. My fault. So what is the S if that's a 13? Is it 8.8? Now, we're just going to stop here because it's just smaller solubility. Now, what happens if it's a common ion? So you will have here initially 0.001. Okay? And then plus S. So you will have here 0.001 plus S. And you're going to has this thing. And again, you can make an approximation that it's still 0.001. So when you have that, so it will be 7.7 times 10 to the negative 13 equals to 0.001 S. So if you divide both sides by 0.001, so this is equals to what? 7.7 times 10 to the negative 1. Now, what can you say? This is lower compared to this one. So this is the solubility at pure water, but if you have a common ion, which in this case sodium bromide, the solubility further decreases. Question? We assume that the S is so small, and we can confirm it because S is just 7.7 times 10 to the negative 10. So it will not have any effect on 0.001. Question. Now, another common ion that we can take into considerations are what we call the pH. Now, this will only affect if there is a common ion that is either what? An H plus or an OH minus. So the presence of a common ion decreases the solubility. So for those that are pH dependent, insoluble bases dissolves in acidic solution, insoluble acids dissolves in basic solution. So take for instance with the example that we have here. So what do you think happened at higher pH? What happened to the hydroxide concentration? Anyone? Will it go high or go low? Will it increase or decrease?
Decrease.
Okay. So as you could see, if you go higher pH, if you're going to recall your lecture, so babagsak kayo lahat sa exam pag yun yung sagot nyo, as the pH go up, okay, the concentration of your hydroxides go up because higher pH means basic solution and hydroxide ion means basic solution. Is that clear? If the pH go down, okay, what will happen is the concentration of your hydroxide will also go down. Clear? So that means this one, which is insoluble bases, they dissolve in acidic solution. Why? In acidic solution, okay, where your pH is low, your hydroxide concentration is low. Why do you think it's low? It will react with H plus. So when OH minus reacts with H plus, the OH minus is removed. Okay? So when it is removed, more magnesium hydroxide will be dissolved. Now at higher pH, where the concentration of hydroxide increases, you add it. So when you add it, there's less concentration. Now, this type of problem can also tells us at what pH will this effect happen? So how do we solve that? Okay, we're going to solve it the same way that we solve the solubility problem. We don't have anything here, and this is what? Plus S plus 2S. So you have an S here and you have a 2S here. And when that happens, what will happen? Okay, we have the KSP equals to magnesium 2 plus OH minus squared. And then we replace it with the S, 2S squared. So you have here what? 4S cubed. And the KSP that you have, magnesium hydroxide, 1.2 times 10 to the negative 11. So what do we do with that? Divided by 4. And that's the cube root. And what do you get? Anyone? So the answer would be, what do you get? S would be equals to 1.4 times 10 to the negative 4. Now what is hydroxide? It's 2S, right? Or 2 times 1.4 times 10 to the negative 4, which is equals to 2.8 times 10 to the negative 4. And you get the POH, that is equals to negative log 2.8 times 10 to the negative 4. So ano yung POH mo? So that is equals to 3.55. So sa pH, ano siya? 10.45. So anong interpretation nito? Higher than 10.45, what happened to the solubility? And lower than 10.45, what happened to the solubility? So at pH higher than 10.45, more soluble or less soluble? So at pH higher than 10.45, so that means higher yung so ano mo, hydroxide mo, lower yung solubility mo. At pH lower than 10.45, lower yung OH hydroxide mo, magiging higher yung solubility mo. Gets? Question. Nagets ba? No. Yeah, kasi pag mas marami yung hydroxide, ano mangyayari? Yung backward reaction yung nagpe-favor. So kapag backward reaction yung nagpe-favor, mas less yung nadi-dissolve. So mas less yung solubility. May tanong? Last tanong?
Wala po.
Okay, so the next thing that we're going to do is the last part of this what we call the module. Ito yung complex ion equilibrium and solubility. So whenever we have a complex ion, this is just an ion containing a central metal cation bonded to one or more molecules or ions. So when you have a complex ion, usually you have a charge. So charge, giving you a charge. Unlike before, solid yung isa, aqueous yung nasa product for KSP. But here, aqueous, and then aqueous. So if you have a complex ion, it is soluble in liquid. Okay, so a complex ion, you have this so-called formation constant. which is Kf. And the way that you write it is the typical equilibrium expression or law of mass action. Products of products over products of products of products over products of the reactant. And usually the higher the Kf, the more stable is the complex. Okay? So example here, you have cobalt with water ion. Okay, you can make it into another complex ion by adding HCl to have cobalt with Cl for 2-. So the effect of the complexation on the solubility, usually it makes it soluble. So for instance, you have silver nitrate and NaCl, you form a silver chloride. So the way that it happens, when you mix it like that, and then in the end, it will be like this. So how are you going to make it soluble? You add ammonia. Okay, so what happened? Your ammonia will react with the NH3 plus that you have there. So usually 2NH3. So it will give you silver ammonia complex. So ganito yung itsura niya. Okay, so from this, when you add the ammonia, magiging soluble siya. Now, if you're going to look at the Kf value, what can you say? What can you say on the Kf value compared to the other? Ka, Kb, Kw.
Maliit po.
Ano yung maliit?
Malaki po. Yung, sorry po.
So malaki yung
Formation
value.
constant.
Okay, malaki yung K value nito. So that means this is usually a one direction reaction. That's what it means. Okay? Kaya kahit na meron kang silver chloride, pag nilagay mo yung ammonia, mas prefer yung silver ion mag-bind sa ammonia kaysa doon sa chloride. Iiwanan niya yung chloride. Okay? Now, there's a sample calculations of this doon sa recorded lecture na nasa module. I hope you can watch it. Okay? Now, the last part that I have here for the module is just, ano use nito? So, I don't know if you're doing cation analysis in your 18.1. Ginagawa niyo ba yun? Okay. I'm not teaching 18.1 kaya hindi ko alam. Are you doing that? Yung mga 1-1. Do you have a cation analysis in your 18.1? So usually in a cation analysis, you have a mixture of cations and you separate and identify them. So to do that, you take advantage of the solubility of each of the cation. So usually there's 5 groups. The first group is the chloride groups. The precipitating agent is the HCl. Okay. And you can separate them based on the solubility that you have. So to separate lead, that's the most soluble. You just put hot water in it and it will dissolve the lead chloride, separating it from the mercury and the silver. Now to separate mercury and silver, you add ammonia. Your silver will form a complex with the ammonia, while your mercury will remain in the solid form. Now, for group 2 and group 3, your precipitating agent are both these hydrogen fluoride generated by thioacetamide. And this is described rotten egg smell, yung amoy ng bugok na itlog. Okay? So the difference, group 2 will be in acidic solution, low pH, and group 3 will be in basic solution or high pH. Now, the other one, if you're still going to you will not still able to isolate them by precipitation, you use sodium carbonate to separate the group 2, group 2A metal. Okay, and those that doesn't precipitate, they are known as the soluble cations like potassium, sodium, and ammonium ions. So if you're going to look at the schematic diagram, this is how it's being done. Now, usually, another way for you to identify them is using the flame test. They will give their own signature color, like that one that you have: lithium, sodium, potassium, and copper. And that's N, module 6. Question. Ano? Because our next one will be electrochemistry. Tanong. Tanong, class. Wala.
Wala po.
I'm trying to find something. Okay. Next thing that we have, equilibrium. No, electrochemistry. So, electrochemistry, kita niyo ba electrochemistry?
Yes.
So this is just based on the what we call redox reaction. So I'm not sure if you have discussed redox reaction. So redox reaction is just transfer of electron. So there's a loss and gain of electron. But before we identify the redox reaction, we have to know or learn a concept. So the first concept that we have to know, I mean, one of the most important concepts we have to know is the so-called oxidation number. Because we will only know if there's a redox reaction, if there's a change in the oxidation number of the element from the reactant side going to the product side. So is this the first time for you to hear this term? Class? So oxidation number is just like an arbitrary number, which is just the charge the atom would have in a molecule or an ionic compound if electrons were completely transferred. Now, all you need to know is the set of rules of the oxidation number, and you will be okay in assigning oxidation number in each element. So the first one that you have is free elements or a combined state have an oxidation number of 0. Okay, so here you have sodium, beryllium, potassium, lead. They are all 3 states. So solid sodium, solid potassium, solid lead, metal. Okay, and then the hydrogen gas, oxygen gas, and then the phosphorus. So that's all 0. Okay. Now, If they are in their ionic form, the oxidation number is just equals to the charge. So that means you have different what? Free oxygen compared to the oxygen ion. So free oxygen is 0, okay, while oxygen ion is -2. Fe can be 3 plus, that's plus 3, or Fe2 plus, that's plus 2. Okay, so that's the main difference between the two. And then in terms of oxidation number of the oxygen, as I've told you, free oxygen is 0. Oxide ion or oxygen ion, oxide ion, that's -2. But if you have a peroxide, the charge of your oxygen is just -1. So that's the special case of oxygen. And the same thing that we can say on special case of the hydrogen. So H2 would give you what? 0. H plus would give you +1. But if you have a calcium hydride, when your hydrogen is in metal, it is a special case situation, special situation, so it's a -1. But number 5 that you have there, you just stick to this what we call ionic form. Or you could say all group 1A or 2A metals, when they become ionic, okay, or ions, they have a charge of +1 for group 1A, +2 for group 2A, -1, 7 minus 8 for group 7. And then for group 6, like oxygen, it's 6 minus 8, which is -2. Okay, and the thing that you need to remember, the sum of the oxidation number of all atoms in the molecule or ion is equal to the charge of the molecule or ion. So let's try to do this thing. Okay, so you have here hydrogen, carbon, and oxygen. So assign the one that you know. So this one is +1, this one is -2, and you don't know this thing. Okay, so you could say +1 plus C plus -6, because -2 times 3 is -6 equals to the charge, which is -1. So you combine them, so you have what? +5 minus 6, so this is -5. So if you assign this one, so C is equals to -1 plus 5, giving you +4. So if you're going to combine them, +1 plus -4 plus -6 will give you -1. And they always assign a question like this. The oxidation number, that's what they call it. Okay? Question? Tanong? Given, kita mo yun, no? Di ba -1 yun? Tanong. So the next thing that we're going to do is assign here. So it's just the same as what I did. So in an electrochemistry, usually the redox reaction that you have, you produce energy or you use energy. you produce energy from a spontaneous reaction, or you use energy to make a non-spontaneous reaction spontaneous. So we have this. Let us assign the oxidation number for each of the element here. Sige nga. So, ready na? So, ano magnesium? So here, what do you have here? Anyone? So these are both what? 0. Because they are free element. Okay? So magnesium is 0. Oxygen is 0. It's not negative 2. It's not positive 2. That one would be here. Why did I assign 0 here? Anyone? Bakit 0 itong magnesium metal at oxygen gas? Huh? They are free elements. They're not bonded. They exist as it is, unlike this one. So is that clear? Now, what happened here to the magnesium? From 0, it becomes what? Positive 2. And oxygen, from 0, it becomes negative 2. Ano to? Nag-loss or gain ng electron? Magnesium. It becomes more positive. So it becomes more positive. It what?
Lose electron.
Okay. Then if you lost electron, you undergo oxidation. And you also serve as the reducing agent. Is that clear? The Leora, lost electron, oxidation, reducing agent. Now, the oxygen, on the other hand, from 0 to negative 2, it gained electron. Kasi naging negative eh. So it undergo reduction, and that serves as the oxidizing agent. Okay? So, first one lost electron because the electron is in the product side. The second one, it gains electron because the electron is in the reactant side. So you have to remember this. Because you're going to be asked a question, which element lost electron, which element gained electron, which element is oxidized, which element is reduced, or what is the reducing agent, and what is the oxidizing agent. So those are the questions that you have to expect. So the difference between which one oxidized, which one reduced, which you can answer by element, the reducing agent here is the whole metal, and the oxidizing agent is the whole oxygen. Okay? So only if there is a change in an oxidation number like this, you have a redox reaction. If there's no change in the oxidation number, then there's no redox reaction then. Are we clear? before we go on the balancing, the last part. So how do we balance Fe2 plus oxidized to Fe3 plus by dichromate in acidic solution? The first thing that we're going to do is we write the skeletal form. So Fe2 plus reacting with dichromate to produce Fe3 plus and chromium 3 plus. So what's the first thing that we do after we write this one? What's next? Anyone? What do we do next? Okay, we assign the oxidation number because that's the only way to determine which one is oxidized, which one is reduced, because the next thing that we're going to do here is we separate them into reaction. Okay, so you look at the what we call the elements oxidation numbers. So this is +2, this is +3, this is +3. So for the dichromate here, so this is +2. So +2 times 7, so that's -14 equals to -2. So that means the 2Cr here is just equals to what? 6. 2 times 6 will give you 12 plus -14 give you -2. So this is a +6. So which one is oxidized? Fe or Cr? Which one is oxidized? Is it the Fe or the Cr? So if it's Fe, so you write here Fe2 plus to Fe3 plus. And the one that is reduced is Cr2O7, 2 minus 2 Cr3 plus. And then you balance the elements other than oxygen and hydrogen. So the only thing that you will balance that is this. Because Fe is already the same on both sides. Dichromate, one has 2 chromium on the reactant side, while only 1. So to balance them, you add 2 for the chromium 3 plus. Okay? And then what you're going to do, okay? So you have Cr2O7 2 minus producing 2Cr3 plus. So for every oxygen, you're going to add water. So how many water will I add here?
7.
So I'm going to add 7 water because I have 7 oxygen on that side. So when I add 7 water, I introduce how many hydrogen?
7.
14 hydrogen, 7 times 2, right?
Yes, po.
Okay, so I have to introduce here 14 H plus. So I now balance them in terms of the atoms. So the next thing that I'm going to do is I need to add electrons to balance the charges. So the first one that I have, Fe, what's Fe I have there? Fe2 plus, producing Fe3 plus. So saan nilalagay yung electron dito? So both sides will now have +2 here, +2 here. Now how about here? How many charges do we have here? 2 plus 2 times 3 plus, so this is +6. So -2 plus 14, so this is what? So to make it +6, you need to add 6 electrons. So 6 plus 14, that will give you what? 8 electron plus -2, so you end up with +6. So what do you do now? You equalize the number of electrons in the two half reactions by multiplying the half reaction by appropriate coefficient. So I have 6 here, I have 1 here. So what do? Swap. I multiply this by 1 and I multiply this by 6. So I cancel out the electrons because they're now the same. And then from this, what will I do? I'm going to add everything. So I have 14H plus Cr2O7 2 minus plus 6Fe2 plus producing 2Cr3 plus 7H2O plus 6Fe 3 plus. You follow?
Yes, po.
And we count. 14H plus, so 14H, 7 times 2, 14. 2Cr, 2Cr, 7 oxygen, 6Fe, 6Fe. And then we go with the charge. So you have here what? Plus 14, negative 2, plus 6 times 2, 12. So overall you have what? 24, right? And then you have here 2 times 3, that's 6. 6 times 3, that's 18. So that's plus 24. So you now have the balanced reaction in acidic solution with this one. Question. Now, what if instead of acidic solution, you are asked to do it in a basic solution? What do? So when you are asked to make it into a basic solution, you add hydroxide to both sides of the equation for every H plus that appears in the final equation. So if you're going to look at this, I have 14 H plus on this side. So I'm going to add 14 hydroxide. So if I add 14 hydroxide, what will happen to this? They will form 14 H2O. So since I add 14 OH here, I also need to add 14 hydroxide on this side. So wala ka ng H plus kasi nag-react siya sa OH para mag-produce ng water. And then you cancel out, then that is common. So you have 14 water here, 7. So wala na to. Ang matitira na lang is 7. And then you count again. 7 times 2, 14 hydrogen, 14 times 1, 14. 7 oxygen plus 7 oxygen here, 14. So 14 times 1, 14. 2 chromium, 6 Fe, 6 Fe. Charges, negative 2 plus 12, negative, positive 6, negative 14, positive 18. So what do you have here? So this is plus 10, and this is 18 plus 6 minus 14. So I could say this one minus that one will give you what? Negative 14 plus 6. Is that negative 8?
Negative 8.
Plus 18, positive 10. And that's how you balance it now in basic solution. Question. So before we say goodbye, okay, do you have any question?